Hello, good afternoon, everyone. I'm Manoj Raheja. I'm a PM from Azure Data Explorer team. Welcome to our session on time series and machine learning with Azure Data Explorer. Everyone is able to hear me fine on the backstage? Okay, good. Okay. How many of you have heard about Azure Data Explorer before or used it? Okay, few of them. So I have a few slides for new people who are just getting introduced to Azure Data Explorer product. So Azure Data Explorer, it's not working here. Okay. So Azure Data Explorer is an interactive analytical service for fast-flowing data. It helps you to cut down your time to insights on really real-time data, as well as it's a fully managed service. It's a PaaS service in Azure. You don't have to manage any indexing, nothing. Just data comes in, you ingest it, it caches data across multiple compute layers, so you can query it really fast, and there is no indexing maintenance required or so. And we have auto scale and other enterprise capabilities that helps you to scale really large. And we have intuitive query language that helps you to explore data really fast, specifically scenarios like telemetry, IoT, log analysis, those sensors, very efficient on this platform. So key use cases where you would use Azure Data Explorer is around telemetry analytics, or you have any kind of activity data like events, time series, and so on, where you want to analyze billions of records interactively or do operational reporting on top of it, build automation. So there are some customers that are using us for telemetry as well as IoT scenarios, connected car scenarios, connected truck scenarios. And there are customers who are building SaaS applications or IoT SaaS applications or other type of analytical applications which they actually offer to their customers. So you can, our platform is ISV friendly. So if you're looking at building a multi-tenant solution, you'll have a best offer there. And doing machine learning on top of our platform. For example, like BASF is one of our customer who collects sensor data from a lot of different factories and then do analytics on their plant, multi-plant analysis and so on. So it's a proven technology. It's been there around 2015. Microsoft internally been using most all the services within Microsoft have been using our product from 2015. And this is the same product. We launched it externally. So there are third-party services like Azure Monitor, Security Center, and a bunch of security products, IoT Central, IoT Time Series is using us as underlying platform. And also the same service is being made available for customers to use. It's the same underlying infrastructure. So where would you use in your big data is, if you have data coming in streaming, you can stream data into Azure Data Explorer, where you would maintain a moving window of data, let's say 7 days, 1 month, depending on the need of how fast you want to respond to the queries and your usage pattern. And we cache the data, index the data, so it's available for faster queries for users. And then export data out, continuously export data out to the data lake so you can retain it for a longer term duration. I'll give you an example of an IoT use case where data is streaming in from devices onto any of these services, and it comes in real time into Azure Data Explorer, where you're doing operational analysis and interactive analytics, dashboarding, and all. And there is an export job that runs every hour or 15 minutes that kind of dumps out a file in Parquet format, in partition format, onto data lake, where you could run batch processing and integrate with the rest of your big data ecosystem. The other option is you bring data through batch mode from on-premise or other clouds or other systems through Azure Data Factory, put it into Azure Data Explorer, and also pull from data lake and push it into Azure Data Explorer where it is cached and indexed. And you can use Power BI as a visualization. You can use Grafana. We have a bunch of other visualization tools that we have enabled. We have APIs in almost all popular languages that you can use to automate stuff and integrate with the rest of the Azure ecosystem. So in this session, we are specifically focusing on time series analysis, time series and machine learning. We have another session tomorrow morning where we'll cover the service in detail, and we have two customers, Bosch and GrabTaxi, going to discuss how they use our platform and their experience. So please come to our session. It's going to be here on Friday. So this session, we're just focusing on machine learning and time series. So we have built-in time series capabilities within the system, as well as some ML capabilities like clustering, anomaly detection, forecasting as part of the platform. We have extensibility through Python and R, so you can run inline Python within your query. And we have integration with Spark. We have Spark connector, Jupyter extension, as well as Python and R SDK that makes the machine learning very easy through to integrate with our platform. So as I'm showing you this, showing you a demo, think of an IoT use case. And time series is applicable in many different use cases, but I chose to demo one of the IoT use case. You have thermostats around the rooms or in a factory or somewhere, and they're sending sensor telemetry, which is coming to IoT Hub or Blob or Event Hub, and that is being ingested in near real time into Azure Data Explorer. Now, how would you go and explore that data, and what kind of capabilities we offer out of the box? So we are not covering how data is ingested into us. We have a documentation. You guys can free to go look at it. We'll just focus on once the data lands, what kind of time series analysis you can do, and what kind of machine learning you can do within the platform. Okay. Just taking time to visualize. Okay. So the way to use our service is you're going to go to Azure portal, look for Azure Data Explorer, provision the service. So when you provision the service, you get it's basically a cluster where you get minimum two compute nodes, and it has a storage attached for persistent layer. And then there are different ways you can plug in. We provide managed pipelines to get data from IoT Hub, Event Hub, Blob Storage, Data Lake. So you don't have to code anything. As far as data is landing onto Azure, onto these endpoints, we can easily ingest and cache it for you. So in this particular example, I already have a cluster called Ignite Source East 2. This is deployed in an East 2 region. And I have a bunch of databases. One of them is occupancy database. And I've already pre-configured it to listen to a blob storage where data is constantly coming in. This is a simulated data. There's a constantly thermostat data has been landed into blob storage where we are pulling it automatically and making it available. So the time it lands into blob storage and time it comes into here, it's about like 100 seconds or something. We can configure that. But the simulated data lands every 30 seconds, so that's why there's that much time is taking. So in this case, a data for thermostat is landing. Let's look at some other data. So the tool I'm using here is our web UI, through which I can connect to my cluster and explore my databases. You can create tables with some schema. You can also create functions and wrap your code in there. So in this case, the data is already coming into my table thermostat. So let's look at it. So I have in-queue time is the time when the data landed into IoT. I have some event type. I have device ID. And it's sending a bunch of sensor telemetry like battery level, temperature, humidity. Now let's start analyzing. This is a very simple use case. There could be more complicated use case where you're collecting more parameters. There are scenarios where customers send, every device may have a different schema and sending different type of events. So you could do that very naturally on our platform. So we just look at sample data here. Now we'll start analyzing it. The first query I'm running here, and the language that we are using is called KQL, Kusto Query Language. This is the same language exposed through Azure Monitor, App Insights, Log Analytics, and our other products that Microsoft support. So we start with the table name, and then where clause, where device ID equals to something, and I want to just look at some data for one device. Okay, so I just pulled that data for one device, and the data has been coming every 1 minute, 30 seconds or so. Now, the next question I want to answer is, what is the average temperature every 1 minute? So it's very simple. I'm filtering for device ID, says summarize average temperature by. So this is where it makes it very easy. So I just say bin by 1 minute. So it's going to chunk, normalize the data and give me average by 1 minute. Let's look at this data. And simply, if I want to change the window, it's very easy. I just need to switch it to like 5 minute, 10 minute, 15-minute window. I can easily change and analyze on the fly. So doing aggregates on the fly is very efficient in this platform. So you just need to push raw data and then do aggregates on the fly when you're querying the data. There are also some scenarios where you may have to like pre-aggregate and keep it for some other things, but most of the cases, the aggregates run really fast. So I just did a simple aggregates, but there are hundreds of different aggregates that you can perform, including advanced analytics. So we just look at the trend of my data every 1 minute. So I told that data is coming every 30 seconds. By looking at this chart, can you figure out if there is a missing data for any specific time frame? Do you think the data would be complete based on the chart you're seeing? Or even if you look at the table, if you just glance it, you say, yeah, data is coming every minute. I don't see any problem. Now, let's look at some other feature that you can use called make series. So with make series, we are going to create a series of data specified with aggregated value for a specific time window. This is like we creating a consistent time series data set. Let's run that. Now see, I'm seeing a bunch of missing data here. Now, the data set that I got here is an array for a consistent time frame every minute. If there is no data for a specific minute, it's still going to show that timestamp here, and then the corresponding value. So see, I can see here there are like multiple zeros here, where I haven't received any data for those time frame. So it's very easy to like detect what is my missing data in my time series. Now, this is a simulated data. I understand that, yeah, my device only sends every 30 seconds, and there's not going to be a huge difference between in the temperature in 1 minute. So I just want to ignore this and then normalize my data. The next step I can do is I want to fill those gaps. So the next query I'm running is where device ID same. I'm doing an average using the make series operator, generating an average by average of temperature. Same window for 5 hours, last 5 hours, bin by every minute. Now, the additional thing I'm doing here is I'm using another operator, time series operator called series fill linear. So what I want to do is find out all the gaps in my data and fill it linearly. So we're going to perform a linear interpolation of the missing values. Now look at it again after that. So now all my missing values are gone, which were showing zeros. Now they are filled with, and it's much more better. So the other ways you can find missing values and go investigate, what's happening with the device, why the device is not sending my data, what happened during that time. Now let's move on. Now we want to figure out, now I understand that there is a temperature I'm getting. Like what will be the temperature 15 minutes later, in next 15 minutes? So I want to forecast. I want to do a time series forecasting. Again, that's built in. So I'm just using we went through a base query. We are just looking at simple trend, and we are just adding one line every time we are trying to do advanced analytics. So we're just building one on the top of the other. So now here, I want to understand what is my temperature going to look like after 15 minutes. So until here, it's all the same data we looked at it. Let's pull it. So I have same time series consistent, and I have another variable that I defined where there is no gaps. I fill the gaps with linear. Now I want to use another operator called series decomposed forecast, and then say that, hey, forecast for 15 periods. So in the period here means my period is 1 minute period. So if it is 1 hour, I would say, forecast it for 60 periods or so. So in case I'm saying forecast it for next 15 minutes. So this is my data. It ends here, and then it generates the forecasted values for me. It works on a series decomposition, so looks at patterns in your data, and based on the pattern, it recognizes what would be the next value. So now we looked at understanding gaps. We filled the gaps. We did some forecasting. Now let's say we want to detect, are there any anomalies in my data? So I do see these spikes and all, but which ones are critical or not. So again, this is my base query. I'm not changing anything here. I'm using another operator here called series decompose anomalies. Again, these are all built in. You don't have to be a data scientist to use it. Just go through documentation, turn some knobs, and you should be able to use it. And all these operators runs at a scale in a distributed way on the multi nodes. And I'll show you how we run it on billions of rows. So now I'm going to go and do an anomaly detection. So it identified some anomalies here. If I'm not happy with that, I could tweak the sensitivity and make it more sensitive. So you can tweak it and then and what makes sense. So now I detected anomaly on that particular devices. Now a question would be, hi, it's okay. When I do analysis, I look at multiple devices. How do I understand anomalies in multiple devices and just focus on the time frame that I need to pay attention or need to go investigate? So the last query here I'm showing you here is same thermostat, but now I removed the filter where clause. So in all queries, we're using where clause, where device ID. Here I removed that filter. Now we're going to look at all devices. So let's run few lines here. So we have now all devices. We have the array for all the devices, the time, as well as their value. Now we're going to feed that whole thing into series decompose. So, and then go and figure out, only give me the rows where anomaly equals to 1. I need to increase the whole. So in this case, we went through all the devices. We got all the time series data. We generated anomaly for every time series that we have. And then from that, we filtered only the values where we see anomalies. So now I can go and figure out, hey, what's going on with this device on this time? Something went wrong because the value that it's reporting is anomalous. So you can build automation around it and just focus your investigation on the critical things. So I just showed you single time series as well as multiple time series. Switching to multiple time series is just by adding another variable here saying by device ID. It could be by device, you can have show me anomalies by temperature, by humidity, by something else. So you can have multi-dimensional analytics out of the box. Now what we have been running is I started running this simulation yesterday. So it's not much data. It's about like 8,000, 10,000 rows. But let's see, if your data grows into billions of records, whether this will perform. So for that, I'm switching to a different data set. This is a TRIPS data set. Which is about 1.5 billion rows. It's already preloaded. Similarly, data which has ride information of people taking rides in New York City. So we're going to do the same thing. We're going to go and look at the trend. This is running on 1.5 billion rows, just under a second. We can do some simple statistics on the data. These are all built in. I'm just saying series stats. Let's do some moving average. Now so this is my original data. Sorry. Yeah, this is my original data, very spiky and not very, let's say we want to smoothen it. So we are doing a moving average. Just by calling some feature of one operator in the system, you can do this at scale. You can do regression analysis. So if there are situations where you want to suddenly detect change in your time series data, so you can do regression analysis. We support both single line fit, two line fit. Or you can use series decompose. There are scenarios where you may want to split apart the time series and look at different angles. Like you want to look at the trend, you want to look at baseline, you want to look at seasonality. So you can actually split the time series and then do it. It runs really fast on the whole platform. Now I showed you built-in capabilities. Now the thing would be, hey, we have a very custom scenario. This doesn't meet my need. Anomaly, I want to do it in a different way. I want to consider some other variables. I have a historical data. So for that, we have extensibility through Python. So it's the same data set we are going to use, thermostat readings that are coming in. Now I wanted to cluster those thermostat based on the values that I'm getting. But for that, the most efficient algorithm, let's say I found is k-means. We don't support k-means, but Python supports. So in this case, you can embed your Python code. So this is my Python code. This is enclosed in quotes, but you can keep your Python file and just give a link to a Python file, and we would just read that during runtime. So for simplicity, I embedded the code in Python code here, so we can look at it. So what I've done is I've defined a custom UDF, a function, and wrapped all my Python code. Let's say I'm a data scientist. I know what I'm doing. I know how the code works. Once I'm ready, I'll operationalize it at a function. But let's say a data engineer comes or a user comes and they don't know what's the complexity. They're just interested in sending input and getting output. For them, I'll just make it as a custom UDF, and as an user, you will just call the custom UDF. So this is the same table we were looking at earlier, thermostat. I added an additional column called cluster ID, so we can cluster the records and then look at it. And all that I need to do is call the custom UDF, pass the parameters. So now in this case, it's going and querying the data, sending the data to the Python engine, which is on the same compute node where the data is, and generates the output, and then here we are displaying the output. If I were to go do some more work on this, I simply need to expand this, and then I can do filter and just use all the other language capabilities. And as you type queries, the syntax will guide you through the IntelliSense will guide you through the syntax, and all the documentation is available here. So this was an example of unsupervised learning, where I just throwed in data, ran k-means, and got it. Now there are scenarios where you may want to do supervised learning, where you have a lot of historical data, you're generating models, creating machine learning models, and you want to score them as the data is coming in, or score them on the live new data. So let's say this is, I'm using a Jupyter notebook. And in Jupyter, we have an extension called KQL Magic. So you can install that KQL Magic in any Jupyter open source installation. And that will make it very easy for you to connect to Azure Data Explorer cluster, run queries and all. So in this case, we have pre-installed this plugin, loaded the plugin, and connected to our demo cluster, and did a bunch of standard training stuff. So we are reading data, doing training, test training, all those things. The main thing to highlight here is, at the end, we're generating a model. So generating a model in a pickle form, then generating a hex file out of that hex file, converting into a hex format, and then we save that hex format into the database. So when I come to the database here, I've already inserted that model in the form of string. So now when I ran the Python code, it converted the model into hex format, and I saved that as a string here. So this is my model. Now, all that I need to do to use this model in my queries is define another user-defined function. In this function, we are reading data from the model. So this is a table. So this is the table we are querying. So we go read that model, send it to the Python engine, and do the prediction here. So again, this is a very simple way to operationalize in the database. Now, as a user, just run the query, call the custom function that we wrote. Let's run it. So in this case, I'm sending those humidity, temperature, all the data to this Python function, which is loading the model, will score it against that, and give me the results. So in this case, we are predicting, based on the humidity, temperature, and other sensor data I have, is the room occupied or not? So in this case, we just send all that data, and it came back saying, did I run the other one? Yeah, so it says whether it's preoccupied or not. So you'll say mostly it is false. It's a dummy data. But let's say prediction came back it's occupied or not based on how best you have trained your model and how accurate it is. So I showed you built-in capabilities where you don't need anything. Just push your data, run queries, compute on the fly. You can automate stuff to pre-compute and store it, so you don't have to compute every time. I showed you unsupervised way, like through Python extension, and this is again through Python extension, Python plugin, but we are training the model inside the engine. And the Python plugin that we have today supports distributed in parallel. So if you have algorithm which can take advantage of distributed computing, you can distribute it across different nodes and run it within the engine. We also support R language in a similar fashion. It's instead of Python, you call the R function. So that's what I wanted to show you around time series and machine learning capabilities. There's a lot of documentation on our website. So if you go to Azure Data Explorer, search for Azure Data Explorer documentation, you would find tutorials. There are how-to guides on how to ingest data from different sources, how to visualize it, and so on. I go to reference in queries. You'll find a separate section for machine learning, doing time series analysis, and I just showed a few of them. There are so many built-in operators that are already available that you can utilize. These operators are optimized for running at really large scale as part of the system. And we're going to have a session tomorrow as well. I don't have the location here, but we're going to have session tomorrow at 10:30 a.m. On Azure Data Explorer and how other customers are using our platform. With that, we end the presentation. If there are any questions, I'm going to stay here after the presentation, and we can discuss, or see us at our booth. We are in the data and AI area near the THR5 section. Look for Azure Data Explorer booth, and we'll be happy to discuss with you. Okay. Thank you.